Graph Theory Class 8 Video 2. In this video we're going to talk about special graphs. In particular we're going to talk about bipartite graphs. Let's begin with the definition. So the definition says a graph is called bipartite if its vertices can be partitioned into two disjoint sets so that every edge has one end in one set and the other end in another set. This is a very abstract definition, and an important thing to point out about this definition is this word can. Okay, it's similar to this situation for planar graphs. Okay, it's important to realize that it might not be obvious that it's possible to partition this vertices so that this definition is true, but the graph might be bipartite nonetheless. Okay, so let's just do some examples. So sometimes it's very obvious, like if I draw a graph like this. Okay, this is a bipartite graph because you can see I've partitioned the vertices into two halves, like a pink half and a yellow half, and all of the edges go from the pink to the yellow, or the yellow to the pink, or it doesn't matter which direction, but there's no edge which connects yellow to yellow, and there's no edge that connects pink to pink. So this is a bipartite graph. Okay, let's do another example. I could do, so let me just do this. I could do this graph here. This is still a bipartite graph. It looks a bit different, but if you think about it, I could consider this one the yellow vertex, and like all of these ones the pink vertices. Okay, there's no edge that connects a yellow to the yellow, and there's no edge that connects a pink to the pink. So this again is bipartite. Okay, let's do a slightly harder one. So I could do something like this. Okay, so is this bipartite? Well, you know, it doesn't look as simple as the first one. It's not as obvious how you divide the vertices, but it might still be possible to divide the vertices into two disjoint partitions so that there are no edges between them. I could do something like this one's yellow, this one's yellow, this one's yellow, this one's pink, and this one's pink. And I think if you check, there is no edge between a yellow and a yellow, and there's no edge between a pink and a pink. All the edges go from pink to yellow, or yellow to pink. So this is bipartite as well. You know, the point I'm trying to really drill into your heads is it's not always obvious if a graph is bipartite. The nicest way of representing a bipartite graph is like this. This is very nice. You can put the pink vertices on the left, the yellow vertices on the right, and it's really clear what's going on. But it's not always as simple as this. Sometimes the graphs look more complicated. Okay, so these are bipartite graphs. Let's move on to a modification of the bipartite graph. So a complete bipartite graph is a bipartite graph where every vertex in one of the partition sets is connected to every vertex in the other partition set. Okay, so we know what a bipartite graph is, and we know what a complete graph is. A complete bipartite graph, it's this idea where you have as many edges as possible while still being bipartite. Okay, like you can't add every possible edge. You're not allowed to add a pink to a pink edge, but you add every possible pink to yellow edge and every possible yellow to pink edge. Okay, we denote complete bipartite graphs by k subscript n comma m. So this is more confusing than the normal complete graph, because for the normal complete graph you would just say something like kn, but now I need two numbers. And what do these numbers represent? They represent the number of vertices in each of the partition sets. Okay, let's just jump straight into doing some definitions for this. So example, if I look at something like K23, what is this? it's 2 vertices in one partition set and 3 in the other, and then all the edges possible. Okay, I can't add this edge because that would be an edge between 2 vertices in the same partition set. So this is K23. How about if I do K3, 1? That's 1, 2, 3, 1, like that. That's K3, 1. And again, when you're talking about special graphs, you're talking about them up to isomorphism. So the exact way I draw them doesn't matter. Like, I could have drawn this one like this. This is still K3, 1. Okay? It's still K3, 1. Let's do maybe one more example. So K3, 3. This one's a bit of a messy one. So I do 3 vertices on the left, 3 vertices on the right, and then I add as many edges as I can while maintaining the bipartiteness. And that's it. I can't add any more edges. Okay, so this is K3, 3. One thing you might notice about bipartite graphs is there's sort of like a symmetry going on. Like K 1, 3, we said looks like this, yeah? But K3, 1 looks like this. But these two graphs, they're isomorphic, okay? So in fact, you have that K1, 3 equals K3, 1. They're the same graph. We consider them to be the same graph, even though they have two different names. Like you could call it K1, 3 or K3, 1. They're actually isomorphic graphs. Okay, so it's a slight bit of confusion, but the notation is very standard, so we can't go make up our own notation. We're going to use this notation. That's complete bipartite graphs. Okay, and that's the end of this video.